Dear students, now we will start with today's experiment, that is Introduction to Biostatistics used in experimental pharmacology. So whenever we are doing the experiment, at that time we got the lot of data, but until and unless we convert the data into the statistic evaluations, it is do not making any sense. And when we come to know that, at that time we are having a same situation just like this parrot. Why these statistics? But still it is most important. And once we understand how to use the statistics, which are the different tests, what is meant by ANOVA, then it is very easy to us. What is statistics? Statistics is the branch of mathematics that transforms data into useful information for the decision making. There are two types of statistics. One which is called as descriptive statistics, and the another one which is called as the inferential statistic. Descriptive statistic is used for collecting, summarizing and describing the data, while inferential statistics used for drawing the conclusions and oblique or making decisions concerning a populations based only on the simple data. What is meant by variables? See, now these are the terms, those are related with statistics. Once we understand what is mean of that, then it is easy to apply the statistic for the different datas. So what is meant by variables? Variables, that means what? These are the dependent or non-dependent types of variables. That means what? Whatever is going to be changed during the procedure, experiments, etc., or on the basis of these things, either or the data is going to be changed. That all things are called as the variables. There are two types of variable, one which is called as quantitative type of variable and another one which is called as the qualitative or categorical type of variables. The quantitative variables is again classified into two types, one which is called as discrete type of variables and another one which is called as continuous type of variables. See, for examples, suppose that if we considering the amount of road accidents uh, during 1 month, so that is having the specific number, and that number will not be changed if it is restricted towards the specific area, isn't it? So that type of data is called as discrete type of data. But suppose that if we are considering the environmental temperatures, so as the times increase from early morning till night, that environmental temperature is going to be varied. That type of variable we call as the continuous type of variable because it is continuously changed. Qualitative type or categorical type of variables which cannot be having a specific number. Now we will see the one by one. Quantitative type of variables. Definition: it is a variable that can be measured numerically, is called as quantitative variable. The data collected on a quantitative variables are called as quantitative data. Discrete type of variables. It can be defined as a variable whose value or countable is called as discrete variable. On the other hand, a discrete variable can assume only certain values with no intermediate values, isn't it? So for example, students scored in particular examinations. number of accidents on road in specific time interval, number of misprints on a single page of book. That type of data is called as the discrete type of variables. Now, the continuous type of variables. The continuous type of variable can be defined as a variable that can assume any numerical value over a certain interval or intervals is called as continuous variables. For example, weight of animals, because weight is also going to be changed, temperature at a particular time, amount of rainfall, etc. What is the relation between in between these variables? The variables, it is classified into two types, one which is quantitative, another one is qualitative or categorical. Quantitative classify as discrete and continuous, while categorical variables classify as nominal and ordinal, and ordinal is again having the classification like order category and the ranks. Now, the quantitative data can be classified as discrete or continuous, and these are, for example, discrete like number of children in family, number of students passing a state examinations, number of crimes reported to the police, number of bicycles sold in a day, or continuous like size of bicycle frame, weight of plant, time of run in 500 meters, age, etc. And categorical like marital status, political parties, eyes color, etc., etc. So that type of data is called as categorical type of data. Now we will see the how the measurement is done. So there are four levels of measurements are as follow. The first, that is nominal or classificatory scale. For example, like gender, ethic, background, etc. Ordinal or rank, hardness of rocks, beauty, military ranks, etc. Interval scale, for example, Celsius, Fahrenheit, etc. Ratio scale, for example, Kelvin temperature, speed, height, mass, or weight. Now, all these statistical tests are fall into two categories, and they are known as parametric test and non-parametric test. The parametric tests are scale or normally distributed data. What is non-parametric test is used for? It is used for nominal, ordinal, or break assumption of normal distribution. So that for such type of data, non-parametric tests are generally utilized. What is mean by ANOVA? ANOVA is a analysis of variance. Is a technique that partitions the total sum of square of deviations of observations about their mean, that is, into portions associated with one, that is dependent type of variable and an independent type of variable. Independent type of variables in the experiments, for example, factor involve interactions during the reactions, etc., etc. A portion associated with error. It is a technique whereby the total variations present in the data set is partitioned or segregated into several components. Usually, each of these components of variation is associated with the specific source of variations. In any experimentations, it is of interest to know the magnitude of contributions of each of these sources to the total variations. Commonly, ANOVA is utilized for the experiments in pharmacology, agricultures, and chemical experiments. There are of two types. One which is called as the completely randomized design, that is CRD, or which is simply called as one-way ANOVA model. And secondly, randomized block design, that is RBD, or which also known by two-way analysis of variance. Now we will see the test used for ANOVA. The types of test, that is t-test and in t-test, paired or unpaired t-test. The one sample t-test, or simply called as t-test, that is the test if the sample mean for variable differs significantly from the given populations with known mean. Unpaired or independent t-test, it is the test if the population means estimated by independent two samples which is differed significantly, for example like group of male and group of female, etc. Now there is one more factors which is calculated for that, that is called as degree of freedom, simply denoted by df, in which its calculation is done like n1 plus n2 minus 2, where n1 and n2 are the sample size for the two different groups. And for t-test, the formula is given as follows: t is equal to mod of x1 bar minus x2 bar divided by square root of n minus 1 into s1 square plus n minus 1 into s2 square divided by n1 plus n2 minus 2 into bracket 1 upon n1 plus 1 upon n2. So this is what about the formula for the t-test calculations. In later slides we will see how the t-test is done, how it is solved. So in that we again discuss about this formula and how to solve the t-test. Now one more thing in statistics, that is called as hypothesis. What is meant by hypothesis? Hypothesis, that means what? It is the any statement which is given about the value of population parameters, and we have to make a decisions whether that statement is rejected or accepted, and that process we call it as the hypothesis testing. The hypothesis is a claim about the population parameter, and there are two terms, one which is called as the null hypothesis and another one is the alternative hypothesis. The null hypothesis, that is denoted by H0, is a tentative assumption about the population parameters. What is alternative hypothesis? It is denoted by HA, is a opposite of what is the stated into the null hypothesis. The alternative hypothesis is what the test is attempting to the establish. The null hypothesis, that is S0 to population's median is equal to K, where K is the hypothesized median value. When the alternative hypothesis and median ratio is greater than K, at that time the p-value will be more. If it is less than K, then it will be less than K. If it is not equal to the K, at that time the P and K relations will be like that, that is 2P is less than or equal to K. What is P value? It can be defined as the probability computed using the test statistics that measures the support or lack of support provided by the sample for the null hypothesis. Use of p-value. If the p-value is less than or equal to the level of significance alpha, the value of test statistic is the rejection region. The rejection of null hypothesis if the p-value is less than or equal to alpha. This is what about the interpretation of p-value. P-value, that is probability value, will gives you the idea about if it is less than 1%, there is overwhelming evidence that supports the alternative hypothesis. If it is in between the 1% to 5%, there is strong evidence that supports the alternative hypothesis. If it is in between 5% to 10%, there is weak evidence that support the alternative hypothesis. If it is greater than 10%, there is no evidence that supports the alternative hypothesis. So these p-values will gives you idea about whether to be go with alternative hypothesis or not. Now before going to start with the actual t-value calculation or t-test calculations, we have to understand some basic things because these are needed to draw the statistical answer for t-test evaluations. The first one, that is the mean, or which is also called as arithmetic average or arithmetic mean. So it is for a random sample of size n sample. Mean is defined as arithmetic average of data values. For example, it having the formula like x bar. So suppose that x1 to xn are the number of sample. So we have to add all x1 plus x2 plus x3 till dash 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 plus xn and divided them with the number of sample size, that is n. So what are the characteristics? The most common measure of central tendency and which is affected by the extreme values or outliers. What is mean by outliers? Outliers, that means what? The any extreme value which will be greater or less than the normal data sets. Now the next, that is median. It is an important measure of central tendency where the order array of sample size n, the median is the middle number. So what is median? See, suppose that if the data is odd, at that time the middle number is present and that middle number is called as median. And if it is even number, so at that time middle two numbers are taken, then we have to make a summation for that two numbers and divided them by the number of sample. What are these characteristics? It is not affected by extreme values and easy to calculate. See, for example, the data set that is 1, 2, 3, 4, 5, and we have to find out the mean and median. See, as it is odd number, so middle number is present and that is 3, so that means what? The median is 3. Now we have to calculate the mean for this data set. So there are 5 observations, that means n is equal to 5 and the observations are 1 plus 2 plus 3 plus 4 plus 5 and whatever answer will be there, that is been divided by number of observations. That means 1 plus 2 is equal to 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 that is 15. So what is the summation of these data set or data, that is 15. And what are the n? See, there are 5 observations. So n is equal to 5. So 15 divided by 5. So we will get the answer, that is 3. So that is the mean for the data sets, and which can be denoted by the x bar. Now the mode. It is a value that occurs most often frequently into the data sets. There is not affected by extreme value. There is, may not be a mode. There may be a several modes used for the either numerical or the categorical data. Now the standard deviations. It is the square root of average square deviations of observations from their mean. That is average arithmetic mean, which is explained by the formula, that is S is equal to square root of summation of 1 to n in bracket x1 minus x bar bracket square divided by n. Now the standard deviations. Standard deviations, which is denoted by SD. These measures universally used for to show the scatter of individual measurements around the mean in the given distributions. So for calculating standard deviations, there are some steps are given over here, and that steps are uh, also utilized for the solving student t-test, isn't it? So what is the first? You have to find out the mean of the observation x. So whatever data set will be there, we have to add all the observations and divided them by the number of observations. So whatever answer you get, that is called as mean. Find out the deviations of each value from the mean, and which can be determined by the formula x minus x bar. Each deviation is squared is equal to the square of a x minus x bar, and that value are added. For example, summation of x square or summation of in bracket x minus x bar bracket square. The variance is calculated by dividing these sum of the numbers n of observations minus 1, that is n minus 1. Variance is equal to the number of observations minus 1. The variance, that is s square, is equal to summation of x divided by n minus 1, or summation of x minus x bar bracket square divided by n minus 1. When the square root of variance is taken out, standard deviation is obtained, that is denoted by SD is equal to square root of summation of x bar divided by n minus 1, or summation of square root of summation of x minus x bar bracket square divided by n minus 1. So for solving this, we will take one example, that is, consider that 5 boys, when put on special enriched diet, shows the following gain into the body weight. For example, 8, 2, 3, 5 and 12 kgs respectively. And we have to find out the mean weight gain in body and the standard deviation from the mean. So for that, it can be calculated we need a tabular formula where the number of sample will be there, weight gain in kilograms will be there, x minus x bar will be there, and x minus x bar bracket square will be there. So for the data sets which is given in earlier slides, for mean, summation of all the values are 60 divided by number of sample size, that is n, and which is 5 for the given example. Variance s square is equal to summation of x minus x bar bracket square divided by n minus 1. So total will be 66 divided by 4 into 16.5. And for standard deviations, we need to take the square root of the summation of x minus x bar divided by n minus 1, and that summation, that equations can be converted into the formula, that is square root of 16.5, and the answer will be 4.1. Now the standard error of mean, that is the small sample size, the arithmetic mean would be approximately of the same true mean of the whole populations, and it can be calculated by using the formula like that: standard error is equal to standard deviations divided by square root of sample size, which is denoted by square root of n. And taking the above example of calculation, standard error is 4.1 divided by square root of 5 is equal to 1.83. The calculation of mean, that is x bar, is equal to, as we know that the number of these observations are summed togetherly, and the answer is 30. That means x bar is equal to 30. So what is mean? That is x bar divided by n. What is n? See over here, n, that means what? Number of observation. 1 2 3 4 5, that is 5. N is equal to 5. So 30 divided by 5, your answer will be 6. So 6 will be your x bar or mean. So similarly for calculation of variance, that is x square, so it is the summation of x minus x bar bracket square divided by n minus 1. So for this calculation, how it is to be done? See, x minus x bar, your x bar will be 6, as we already calculate the mean. So this is the x minus x bar, that is 8 minus 6, answer will be 2. Same need to be do for each and every observations, and you will get this column, that is x minus x bar, and we have to make a square of that. So 2 square is 4, 4 square is 16. Forget about the minus and positive sign, because when the square is there, the multiplication is there, so that sign is nullified. 3 square 9, 1 square 1, 6 square 36, and its summation is again 66. So for calculation, so summation of x minus x bar bracket square, the answer will be 66 divided by n minus 1. What is your n? That is 5 minus 1, 4. So answer will be 16.5. Similarly, for calculation of standard deviations, standard deviation is equal to square root of summation of x minus x bar bracket square divided by n minus 1. So we got the value of these, that is 16.5, n minus 1 is equal to 4. So directly took the square root of 16.5, and your answer is 4.1, and that is what about your standard deviations. Now how to calculate the standard error of the mean? It is In the small sample size, the arithmetic mean would be approximation of true mean of whole populations, and it is calculated by standard error. SE is equal to standard deviations divided by, which is denoted by SD, divided by sample size and square root of sample size, that is n. So taking the previous value, standard deviations, we calculated 4.1, and the square root of n, that is n is equal to 5, so square root of 5. If you solve these, you will get the answer 1.83. Now the student t-test. It can be calculated by using the formula, that is mode of x1 bar minus x2 bar divided by standard error, square root of standard error square plus standard error 2 bracket square, or t is equal to mode of x1 bar minus x2 bar square root of n minus 1 into bracket s1 square plus n minus 1 into s2 square divided by n1 plus s2 n2 minus 2 into bracket 1 divided by n1 plus 1 divided by n2. Or if we simply size all these equations, we will get the final equations like that: mode of x1 bar minus x2 bar divided by square root of summation of x1 plus summation of x2 divided by n1 plus n2 minus 2 in bracket 1 upon n1 plus 1 upon n2. So this is what about the example for the student t-test. See here, the uh, experiment is done in which the 10 population is taken, and we have to check it out the body weight in a group with high protein diet and in group those are low protein diets. So for group 1 we will get the n1 is equal to 12, and from group 2 n2 is equal to 7, and the summation of x1 is equal to, we have to submit all these figures, these. So we will get the value, that is 1440. If you submit all these values, we will get the value, that is 707. And then we have to calculate the x1 bar. How the calculation of x1 bar will be there? So calculation will be like a summation of x1 divided by n1. What is n1? That is 12. What is summation of x? That is 1440. And x2 bar, for x2 bar calculations we have to again do the same things, summation of x2 all the values, that is 707 divided by n2, that is 7, and we will get the value, that is 101, and for x1 bar that is 10120. Again summation of x1 bar, so 1440, you need to make a square of it. Again for 707 you need to do this, find out the square of these also and these also. So you will get the value of summation of x1 bar, summation of x1 square and summation of x2 square, and which is found to be 177,832 73959. Then we need to find out the values for summation of x1 into bracket square divided by n1. As we know that what is n1, that is the 12, and what is the value of these, that is 7 1 1,77,832 divided by 12, and you will get the value for that, that is 5032. And for summation of x2 bar, x2 square divided by n2 is equal to 71,407. So again we need to find out the degree of freedom. So formula for that is n1 plus n2 minus 2. So 12 plus 7 minus 2 and you will get the answer, that is 17. This is the final formula for the t calculation. Mode of x1 bar minus x2 bar divided by square root of summation of x1 square plus summation of x2 square divided by n1 plus n2 minus 2 into bracket 1 divided by n1 plus 1 divided by n2, and you need to put all the values over here. If you solve these, you will get the final t value, that is 1.89. that is your statistical t-test value for the example. Now we will move towards the multiple choice questions. The first question, that is, a numerical value used as a summary measure for a sample such as sample mean is known as, the options are population parameter, sample parameter, population mean and sample statistic. Correct answer is sample parameter. The next question is the mean of the group of numbers, that numbers are 1, 2, 3, 4, 5 is 1, 2, 3 or 4. The correct answer is 3, that is option C. Again, what you need to do, you need to make a summation of all these numbers, 1 plus 2 plus 3 plus 4 plus 5, divided them by the sample numbers, that is n is equal to 5. Next question is the mode of group of numbers from 0, 1, 2, 9, 4, 5, 6, 7, 9, 8, 9, 10, 11, 12, 13, 14 is 1, 14, 11 and 9. What is mode? That is frequently number which is coming. So the only 9 is the number which is frequently occurring into the data set. See, here 1 9 is there, here again second 9 is there, here third 9 is there, and the remaining numbers are not frequently came. They came only once, isn't it? So that means your mode will be 9. So correct answer is D, that is 9. The value of test statistics that separate the acceptance regions from the rejection regions are called as can never be larger than the population parameter, can never be equal to the population parameter, can be smaller, larger or equal to the parameters, or can never be smaller than the parameters. So the correct answer is C, that is it can be smaller, larger or equal to the populations. What does the probability of rejecting null hypothesis when it is true call as? Type 1 error, type 2 error, type 3 error or type 4 error? The correct answer is 1, that is type 1 error. To test the hypothesis S0 is equal to mu1 is equal to mu2 is equal to mu k, one can apply for regression analysis, analysis of variance, t-test, chi-square test. The correct answer is B, that is analysis of variance. Which of the following symbol represent a population parameter? S, sigma, R, D. The correct answer is B. Mode is the most frequently occurring observation. It is true, false, data is not sufficient, none of the correct answer is A, that is true. Mean is the average value for the data set. It is true, false, data is not sufficient or none of the above. The correct answer is A, that is true. The mode may or may not be exist. Is it true, false, data not sufficient and none of the above? The correct answer is A, that is true.